generating. It's a generative process, and it's down deep in high temperature, high pressure depths. But in all that splitting apart, and in the high heats, it's vapor, steam. Steam pushes up through the rocks and rises, and then as it cools, it condenses. Sometimes it's still hot when it hits the surface, and we have hot springs and geysers and geothermal. Sometimes it cools, and we have cold springs.
Can you repeat for this one more time about what's?
I thought you just had.
I thought I hit play and I didn't.
Oh,
so.
okay.
One more time.
Which part did you get?
The part that it's about what the rock, all the formation that creates this, the formation part, the scientific part of the rocks that makes this happen.
Yeah, when we go down into the earth, we get more pressure because everything's pushing down, and we get a rise in temperature. And when we've drilled exploratory holes in the earth, we found that the temperature went up a lot faster than was expected. Take home message there, traditional geophysicists didn't really know what they were talking about. Take home message there, science is often overconfident in what they assume to be the truth, and then their experiments show them otherwise. So we're learning. It's important to keep that in mind. We're learning as we go. So to the synthesis of water, we were talking about under pressure and temperature and with mechanical, electrical forces of quartz. That's an energy supply to strip atoms off and make water in the Earth's crust.
Because it's compressed all these different frequencies that makes it
Plasma.
turn into plasma, which is everything.
Silica quartz, piezoelectric plasma generated water in the Earth's crust. That's what we're talking about.
High vibration.
Super pure. It's destroyed and remade a million times over. This is virgin water. If you want to,
no memory.
It's a clean, brand new chalkboard. It's easier to structure. It's easier to imprint. It's easier to program. It's a clean slate with the eyes of a child. So that's nice. It's super clean and pure. And
how new is this understanding? This information of understanding, is it relatively new or 20 years ago?
Yeah, white papers going back to 2005, 2014, 2017. So within the last 20 years, around the world, there's some indigenous knowledge about this, that there's water below the earth. That's been talked about for time immemorial.
I just found a giant ocean under the earth.
Yeah. And it's down in there, and there's pressure down there, and that pressure and steam brings it up close to the surface. So there are these little fingers of water that come up close to the surface, and that's where we can access this deep water. And that's where having a good dowser or good geophysical instrumentation comes in, so that you can pinpoint locate where those fingers are coming up, so you can find a shallow, near surface target, so you don't have to drill 5 miles deep to get your water, because that's really expensive and hard to do. It's hard enough as it is. So that's where this technology has really shown, is being able to quickly survey large amounts of property and hone in, and find where those near surface targets are, where those fingers come up, where you can put your straw in the diagonal, vertical little rivulets and streams coming up to the surface.
Yep.
Any questions so far?
So it's like within the lithosphere, there are fissures in the lithosphere. Is that a good way to also think about it?
Yes, that's some great, little more technical geological terms. Yeah, fissures, fractures, faults, these little cracks and splits, weak zones and spaces between the rocks. The water will find those and flow through it, just as water will, take on the shape of the container it's in, and will find path of least resistance. When it's under pressure, that's what gives it its vertical push. Sometimes that water will reach the surface, and when it reaches the surface, we call it a spring. And different springs have different qualities, because each of those terrestrial sources, they had their own journey from the deep on up to the surface. And you walk out of the house, you're freshly showered and clean, and you go on an adventure, and you pick up some foxtails and some mud and things along the way. Water's like that too. The different mineral qualities we find in different sources, you know, what did it travel through on its way to where you get to intersect it.
Okay.
Okay? So there's a lot of water in the earth. It sometimes comes close to the surface. We've been revering, protecting, honoring springs and finding life from them for, you know, as long back as we can go. It's shaped our history. And here's a way where we can find a lot of subterranean springs and put our straws in it, drill a well to it, and enjoy that fresh, pure water. Electromechanical forces, that's a good word for the whole quartz plasma driven synthesis. So drilling a well is kind of a big endeavor, and I'm sure that there's more innovation we can do to make it even easier and cheaper. But not a lot of innovation has come in finding water in the past few hundred years, where, you know, we've put a lot of energy and applied science towards finding oil and gas, a lot of money after that. Why don't we care about water? It's so good. So this is a geophysics approach that somewhat parallels some of the things that oil and gas are doing in how we can and high value mineral chasers like gold miners to how we can find this water. So I'm going to minimize that and open a project. So with our little operation, someone reaches out to us and they've got property and they want to find some water. So how's this work? We'll start out with doing a map study. Someone reaches out to us and they say, we're interested in finding water on our property. How do we do that? We say, well, send us your latitude and longitude and let's do a map study. And we do that for complimentary for people. It takes us about an hour to put together and collect a bunch of data and share it with them. So we'll start with a aerial satellite view of a property and do our map study. And we use a bunch of different apps and tools and toys to do these things. So this is a screenshot from a program called Onyx that allows us to look up properties by the listed owner, and we can see where a property is. These fellows down here, I just located a well for them. They had several lots and wanted to focus on getting a well close to the house. They had an old well. It was like a gallon a minute, wasn't really doing it. So they wanted to find a new well close to the house. So we focused on the area close to their house. And our first tool for surveying a property is called radiometric gamma ray scintillation counting.
Perfect.
What's that mouthful mean? It's kind of like a Geiger counter. It's a listening device for the background radiation coming out of the earth. I'm gonna go over here on the other side of the TV. Here it is. Well, actually, this is just an aluminum tube, but it's in here, and it's hooked up to a little computer. And what's in this aluminum tube? There's a tube in the tube. How about that? And in the tube is a crystal. So this is all crystal-based physics. Airport's always really interested in this. When we get they love hearing about this, right? So this is a scintillations detector, sophisticated piece of electronics. This is built in Germany. The technology is about 35 years old. This was invented by a fellow named Arnon Bickel. And Mr. Bickel is a NASA scientist and was into growing these crystals in a lab that scintillate, which means if someone has a scintillating personality, they're kind of sparkly. The crystal sparkles when radiation hits it. So a gamma wave hits the crystal and emits a photon. And then you can count the light coming out of the crystal, and that gives you a way to count the gamma waves, which are a bandwidth of EMF, which is just non-visible light at a high frequency. And that's coming out of the sun, and it's coming out of space, and it's also coming out of the earth due to radioactive decay of various isotopes, potassium, thorium, plutonium, uranium. There's that stuff down there in the crust, and it's emitting a background radiation, and we can read it with a crystal that scintillates. So what's cool about this is you can use this to do all sorts of things, from monitoring the safety of a nuclear facility to you can use it for prospecting, for looking for gold, because of the way that it'll cause little spikes in the signal. We're using it for a simpler application. We're using it to look for water. Water will depress the background radiation coming out of the earth. Kind of like sunglasses will dampen the brightness of the light. So where the water is in the earth is like a variable sunglasses lens that dampens the overall count. So we walk around and we collect data going around grading a property. There's a GPS attached to that with a little computer, so it records where it is and what the count was, and then we can turn that into a map.
So you said those crystals are man-made?
They're grown in a laboratory with a particular frequency ambient field to help it grow, and yeah, and then that's in a photo multiplier tube, which amplifies the light signal coming out of the crystal, and then a little photon counter. And
How long does it
you.
take to grow the crystal? How long does it take to grow the crystal?
That's a good question. I don't know the answer to that.
Okay.
We'll have to look into scintillating science.
Yeah.
Is that similar to a Vogel cut crystal at all?
No, I don't believe so. Yeah, Vogel cut, like with your particular geometry, and yeah, I don't believe so. So that's kind of what I just explained. So then with the maps we produce, we can see an indication of where water might be. Here's an example of a map made by walking around with the counter, and we graph it such that high is red and low is blue to purple, and we can see the signal of where water is, and often we like lows and we like high contrast areas. Like this is a high contrast area where it changes really sharply, and that can be indicative of a fault where there's water and it's on one side and it's not on the other side. So that's our a clue we follow. And then we use another technology to look down in the earth. And we look down by listening, putting a probe in the ground with a sensitive sensor on it. And we tell the computer to listen to the ground. We listen to about 16,000 data points of passively listening to the way that the earth vibrates at high frequency. Low frequency, we could think of the Schumann resonance is about 8 hertz. We're typically using 3,600 to 7,200 hertz, as low as 400 hertz, as high up as 144,000 hertz. And that difference in frequency gives us a different depth of focus looking down. And through statistical mathematical analysis, we can see where the relatively weak areas are underground.
You can make a 3D map, basically.
Yeah, we can make a 2D cross section, and we can take multiple lines and we can make a 3D map.
You're using some sort of GIS, or what software makes all these cool maps?
This is done on a program called Surfer,
Surfer.
which is some kind of basic GIS type software.
Surfer. Cool.
The first map, Tyler, before you move on, can you repeat just a small synopsis of the first map?
This guy?
Uh-huh.
Yeah, so this is an example of a gamma radiation map. So this is a XY axis looking at the surface of a property.
Okay.
And we do that. I walk around with this and walk back and forth and keep picking a tree to walk to and work my way around a property. Or larger properties, we can put it in the car and drive it. We can hook it to a drone and fly it. We can drive it around in a golf cart. If it's in a car or a golf cart sitting in its case on the seat, the overall count is going to be lower because the vehicle is going to be interfering with the background. But as long as you keep those data sets separately, you can still use it because you're really looking for the relative change.
Okay.
Overall
You
relative
need a
change.
computer, that information is going into a computer.
Yes, it's going into a computer. Got this little guy called a G Explorer for Gamma Radiation Explorer, and it uses a high voltage cable that plugs into the tube, and this little guy on a magnet is a GPS. If I'm driving around in the car, we can put that magnet on the roof of the car or the roof of the golf cart, and this keeps track of, and it just runs off a SD card, and it's keeping track of the date, the time, the latitude and longitude GPS coordinates, and the impulses per second that the photomultiplier 2 is counting. It's kind of like a Geiger counter, but and within you're just attaching your location data to it.
This whole process is fairly involved. Is there like a size parcel or lot or project that you need to get to for this to start making sense? Or can you do like small lots?
We can do small lots with this. Yeah. The smaller the lot, the
Just less work and then.
yeah. As far as surveying go, it's less work. As far as water hunting go, it's less to work with. You really only need one good spot.
Right, yeah.
But does a quarter acre lot have a good target on it versus if you've got 5 acres or 10 acres to look around for? Well, it could, or maybe not. We're looking for what's there. And another little saying is, we'll find where the water is, not where we want it to be. Yeah, but just because you've got a half acre doesn't necessarily mean that you can't have a good well on it.
So if people are coming to you asking for you to look for water on their land for a well, my guess is that they're not asking specifically for primary water. Are you looking for specifically for primary water?
I ideally want to find primary water.
Right.
This technology, we can locate good groundwater sources, and we are more likely to find primary water because of our ability to image what's going on underground and correlating that with the background gamma radiation, which gives us where our water signal is. So we're looking for weak caverns underground that are correlated with the water signal, and that gives us a really high success rate of finding high quality groundwater.
So there's a specific signature that indicates it's primary water.
There are some analytics we can do to analyze it and guess if we have a primary water source.
What is primary water?
Primary water is water that the earth is generating.
Oh,
It's fresh earth crust water. It's got a bunch of other names, including like magmatic water because it's associated with volcanic activity. So it's new to the water cycle water. Now, when primary water is coming up from the crust, there's subterranean water that's part of the water cycle. That's precipitation and snow melt and runoff and rain that gets down into the ground. So sometimes that's mixing with the water that's coming up. So you can find traces of atmospheric water quality water that may be mixing into a primary source. And that makes that detective work of saying, is this definitely primary water? It makes it a little more difficult.
Right.
I say, taste it, test it. Do you have an adequate flow? Is there enough water in there for your needs? Are you getting an abundant amount of water? And then, what's the lab report say? Is it clean and lacking of anything that you want to avoid? Mm-hmm. And if you like the mineral profile and it's a good daily drinker, then great. Yeah, good water is good. Bad water is not good.
And is the primary water generally higher flow?
Tends to be. But what is the size and quality of the finger that you're finding? It's like trying to qualify that all rivers or streams are the same
Flow, right.
flow. Yeah. There are big fingers and there are little fingers. There are rivers and there are rivulets and there are streams. So there's less huge rivers, but you know those can be found. If you've got one on your property, then awesome. Our primary water forefathers have found a great many well like that are really high flow, high quality water. For example, Lake Elsinore down in San Diego. I think we've got a picture of that one here. That was created from a well that Stephen Reese found and filled those lakes. Steve Reese, and Paul Power are our predecessors, and they found a great many wells across California and across the West, and some of them are 1,000, 2,000, 3,000 gallon a minute flows, massive, and those wells are still pumping away today, and their flow rate has been unaffected with precipitation patterns, showing a lack of dependency on precipitation and river flow rate of these wells, which is a huge piece of support to this model, this paradigm of earth-generated water. Clearly the rain or lack thereof isn't affecting the flow rate of these wells, and they're huge. If most residences, if we can get a 20, 35 gallon, 30 gallon a minute well, that's a lot of water. You can fill a big old tank with that and have more than you need.
What are the conventional geologists' reactions to this information?
Yeah, the physicist Heisenberg said science marches ahead one funeral at a time.
That's right, exactly.
Why is that? Well, people tend to get attached to their ideas, and then they attach their personality to those ideas, and then they feel personally attacked if you question those ideas. Or they did their thesis, their PhD, they wrote a book on this, they've been lecturing on this, and you bring out this model that contradicts them, and if that becomes the accepted model, then they become obsolete, and then there goes their career and their importance and their ego and stuff. So
I'd say follow the money.
There you go.
there's that. Yeah, it's money, it's people's self-interest in their career,
grants.
or just emotional attachment to their
Also,
ideas.
grant money that they put to scientists. So certain scientists get grant money and certain scientists don't by
Yeah.
what they support if it goes along with
Yeah,
the political or whatever the agenda
sure.
is at hand.
And humanity's enjoyment of and need for water is nothing new. And wouldn't you know it, there are some powers that be and interests that have coalesced around the issue of water. And, can you believe it? And would you believe that people squabble over who's got, who gets to take so much water out of the river or out of the ag ditch? And, we're so silly sometimes.
And we're on a blue planet.
Yeah, we are on a hydrological cycle planet that makes water, and there's a ridiculous amount of it.
So you're okay with growing almonds in Kern County?
No comment. Monocropping is, I love the bees.
Yeah.
Almonds
Most
are
wa-
desert trees that have been overly watered to make an excess yield.
Yeah.
How about that?
Yeah.
Yes, sir.
About the Joe's place in the planet.
Question about what term do you use to describe water that has never gone through the cycle of being in the atmosphere and back into the aquifers in our waters?
You could call it whatever you want.
Geothermal. Never been in the atmosphere.
I think never's a long
Well,
There's water like that.
yeah, and
I know of
sure,
water like that.
and that's what we're talking about here with primary water. Primary water, virgin water, magmatic water, earth-generated water that's on its way up. And I was just saying with the caveat of how do you know that it is? And there's a caveat of like, well, what if there's some surface water that's coming down and it's below the surface, and then this primary water is coming up from deep, and what happens if they mingle a few hundred feet down and a little bit of that trace gets in there, and then you do some really sophisticated analytical chemistry and you're like, oh, there's atmospheric traces in this water. Well, did it just mingle down below, and then to what extent? And what are you happy with? Yes.
Question. I'm thinking about looking into what it would be like to have a geothermal furnace here. Can that be tapped in with, do you know much about that? And can we, when we get the primary water going, wouldn't it be nice to set that up as the same time with the
When you say
Thermal
geothermal furnace, do you mean powering something off of geothermal? Or do you
Yes.
mean having a furnace?
both?
Okay, well, if you want geothermal, then you have to find it.
That's what I'm asking. Can you do that?
Well, how deep is it right here? You know, it might be shallow, it might be deep. There's hot springs that come to the surface. Other times you might have to drill down a mile or two.
So do
So-
you have the technology to?
We can
Pinpoint
locate that
that.
water. Can we tell the difference between to cold and hot? I'm working on that. Not yet, but I think that would be
Well,
good
the
to figure out.
geothermal furnace, that's how it just, because of the earth stays at a certain temperature, so it's using the earth.
Where's this furnace? Is it in your living room, or are
You
you
have
talking
the
about in the
furnace,
ground?
but you dig down into the earth with these pipes, and
Yeah.
they tap into the earth and your furnace works off of that, and it's a geothermal
Okay.
heating and cooling system. So it's using the electricity from the earth to power the furnace,
If you
or
go
something like that. I'd like to know more, and I want
If
to
you
know.
go down far enough, you'll probably hit hot water.
Okay.
That could be cost prohibitive.
Okay, but I think the furnace heats it, but somehow it's the earth.
It's probably a heat exchange where you take
Something.
the hot water and there's all sorts of things you can
It says
do
it's-
with hot cold heat exchange.
I think you can tap it into a pond too. But I think that if we can find water here, then you can do it at the same time, because you have to dig down.
If there's hot water in the ground that's accessible, then you
Okay.
can do a
I'll
million
send
and one,
you.
you can
I'll
do a
send it
million
to
and
you.
one things with it.
Okay, I'll send it to you. Just maybe you'll see what I'm talking
And
about.
you go far
Yeah,
enough and
sure.
it gets hot, and then finding shallow hot sources and differentiating those from cold, that's something where I feel we can really move this forward. And then also, if we can find the water, drill a test bore and see, is it hot or is it cold? Far enough down, you're going to get hot no matter what, but how far do you have to go, and how much are you willing to spend to get there and do that feat of engineering? Could
So-
be shallow, could be deep. Depends on where.
All right.
I haven't looked down, so I don't know yet.
Okay.
What's the average cost of drilling per foot now?
30 something. Yeah. You're probably looking, budget 40 grand for a well in California. We do these projects for 4 grand for a 10 to 20 acre property. We aim to be a fraction of the overall cost. And, the other question of what's the value of this is
Drilling in the right spot.
know before you drill.
Right.
Drill in the right spot, and these little rivulets and fingers that come up, pinpoint precision is important. If you're in the crack where the water is coming up, you get a lot more water than if you're in the hard rock a few feet over to the side.
Quick question: is it possible to determine the mineral content of the water? So, say for example, I have really, really iron-rich rust water at my property. Is it possible to determine, before you drill, if it's contaminated or not? I don't know.
Not with these tools.
Okay.
Maybe with more sophisticated radiometric spectrometry, you could look for atomic and mineral signatures. But with this survey, no, we can't really tell you that.
So, could you say, well, I'm in the middle of a split, so, I'm splitting my 10 acres into 2 5s, and I know where my well is,
Mhm.
so with this information, could I figure out where mine's coming from, so that he wouldn't tap into that?
Don't touch that finger, that's my finger.
Yeah.
Well, it's
Even if it's
been-
on your property.
Well, yeah, it is.
So you know where to build the
all
underground
now,
well,
but
so they
if
can
I
get
knew
to-
where my water, I've had it 35 years and it's gone down 3 gallons in 35 years, so something's going somewhere.
Mhm.
Long
That's
term.
very common.
Variation happens.
And I heard. I was a little
shift
surprised.
happens.
So I've heard of
The
these
course of the
things on
rivers change course. Streams and rivers will change course, and there's no reason that can't happen underground too. It happens less than like a sandy creek because typically it's hard rock and it's more stationary. If you're putting multiple straws into one source, yeah, that can draw it down.
So is it usually like one source down, or are they?
No, there's so many fingers. There's so many
Continuously-
fingers coming up. There's arteries and there's little capillaries coming off of it, and there's
And your technology will map a property. where
yeah,
those
we'll
figures
map
are.
it and we'll find where those fissures are coming up from deep, and then we pinpoint locate that. X marks the spot and predict how deep it is, and we can also see the relative size of those structures. So a lot of people will drill and hit water and stop. They're like, yeah, I hit water. That water could be a subterranean aquifer, which is snowmelt rain runoff, versus we're looking for a deeper structure that has downward connectivity. I'll show you some pictures in a second. If you're splitting your lot and you're concerned about that, we could survey the whole thing. We could survey the other side, find them a well target, and then you could sell that lot with a identified well target. Or you could
It's just a thought because I sold real estate and I did hear of, at least there was an assumption that a well had X amount of GPMs and then they put a well up above it.
yeah.
And this one.
This is a very
So they assumed that the two.
They assume the two are, yeah, and they're like, hey, you're stealing my water. Yeah, scarcity mentality. There's so much water in the earth. Let's move into,
It's a matter of not wanting to go drill a well somewhere else.
Yeah.
Someone else is taking it.
we've had clients whose well ran dry, and we surveyed their property, and it turned out they just needed to drill a bit deeper. They had like a 160-foot well. We said, go down to 350 feet, and now they have, primo world-class spring water, quality water, and plenty of it. Because they found that finger of water that was coming up that was a deeper target, 300, 400, 500 feet sometimes instead of 150, 200 feet. But then you're getting the earth water instead of the surface water. It's a deeper drill, it's more expensive, it's more effort, but better quality and drought proof.
And you're right, that's the way most people do it. As soon as they hit water or anything on GPM,
Yeah.
as far as the county's concerned, that's as far as.
Yeah. And then you have a 5 or 10 year drought, and the water tables and aquifers drop down, and that subterranean source runs dry. Whereas if you find a structure that's got downward connectivity that's being recharged from below, then that's precipitation independent.
Yep, gotcha.
Good question for you.
Yes, sir.
What would a new drilling rig cost?
Well, what would a new car cost? Depends on the car.
Well, give me what kind of drilling rig do you have and what does it cost?
So if you're gonna get a drilling rig, get a dual rotary, air-driven rig that you can go through hard rock with, and that you can go, up to 800 feet with. I would say that would be the one to get. Though some clients of ours, they bought a antique drilling rig from the 60s, spent some elbow grease refurbing it, and they use that to drill their well, and they've got great water. So there are old classic rigs that may go slower, but things were maybe built to a higher quality back then, and they can still do the job. A new and shiny, big, powerful one will do it faster.
What would it cost?
So the 60s are antiques now?
When it comes to machinery, yeah, I mean, a 60-something Chevy, that's a collector's car.
Another question.
Yeah.
What's it cost for a permit to drill a well here in the county?
I don't know this county's laws. So, two things I'm not a lot of things, but two things I'm not is I'm not a driller, and I'm still learning about drilling. and I'm finding the well site and predicting the depth to the water so that you can budget and plan on the project and work that out with a driller. There's Peters Drilling right here in town. I went and talked with them. They seem really competent and are good guys, and you know they do all their own locating, but they were really interested in this. And then the other thing I'm not is a water lawyer or a bureaucrat, and I do water locating. You know, I've been from here to Texas and in between, and each county's got its own little rules and regulations and hoops and things. Water law can be complicated. It's been an issue for a long time, and there's rules that have grown up around it. So in this county, I'm not sure. That's a water lawyer question, or you know, asking your county water board, or figuring out who's in charge of that, and you know.
Even well drillers will know that information.
Yeah, well drillers will have, a local well driller will have that information. A lot of times they'll handle the permits for you.
Since we're talking about drilling, are they using some of the technology? Because I know, like in fracking now, they've got drills that go sideways and all this crazy stuff.
Yeah, that would be great to use those for water. Yeah, like the offshore oil rigs, they've got these drills that can articulate and go through the ocean floor like that. That would be great. I'd love one of those for water drilling. That'd be super.
Yeah, how much does one of those cost?
Right?
Yeah, there you go.
There are hot springs out there, like in Colorado. I know of a hot spring pool that was found by oil and gas. I don't know if they were looking for oil or gas, but they were exploratory drilling, and they hit hot water, and they're like, oh, that's not oil, and they left. And